image system has spreading code rate of 3.84 megachips per second, and user data rate is 15 kbps, and required SNR to get this performance is 90 with the number of users served by one cell is. Here coding gain is nothing but 3.84 into 10 power 6 divided by 15 into 10 power 3, which is equals to 256. That is 256 for k minus 1 users, that is x for 1 user, that is x equals to 256 minus divided by k minus 1. Here 10 log ax is nothing but 9 dB, which is x equals to 10 power 0.9. So k is nothing but 256 10 power 0.9 plus 1, which is equals to 33. That is, each cell serves 33 users, that is option B is correct. Impedance for the transmission line system shown below. Here Zn dash is the input impedance for the quarter wave transmission line. For that one, ZL by Z0 square by ZL. Z0 square is 50 into 50. ZL is 100. So it is 25 ohms. And for the Zn is equals to Zn dash, because the length of the transmission line is lambda by 2, so which reflects the output impedance towards the input impedance, which is 25 ohms. That is option C is correct. The RLC circuit Vs is 400 volts, which is RMS value, and R equals to 20 ohms, and inductive reactance is 40 ohms, and capacitive reactance is 40 ohms. We have to calculate the Q factor of the series RLC circuit. Here in the data itself they have given as XL equals to XC. That means the circuit is at resonance. In that case, the Q factor is omega naught L by R. Omega naught L is nothing but XL by R. XL is 40 divided by 20, which is equals to 2. That is option A is correct. Comes to the second part B, the voltage across the inductor. VL is nothing but IXL into 90 degrees. Here XL is 40, I is nothing but 400 volts VRMS divided by 20, that is 20, which is nothing but 20 into 40 at 90 degrees, which is 800 at 90 degrees. That is option A is correct. EDSR and VGSR are given as the values of a E MOSFET whenever it is on. VGST is 4 volts and GM is 2000 microsiemens, and RS is 1K and RD is 6K. So IDS on is K VGS on minus VGST square, which is, from this we will get K as 4 milliamps divided by 8 minus 4 whole square, that is 4 into 10 power minus 3 divided by 16, that is 0.25 milliamps per whole square. After getting K, we have to decide an ID, which is here VG is nothing but 15 into 40 divided by 100, so 6 volts. Now VGS is nothing but 6 minus ID into RS, that is 1K, 6 ID. Now ID is equals to 0.25 6 minus ID minus 4 whole square, which is 4 ID 2 minus ID whole square, which is 4 plus id square minus 4id, that is id square plus id square minus 8id plus 4 is equals to 0. This is the quadratic equation we are getting. So if we solve this quadratic equation, we will get id as 7.46 milliamps and 0.53 milliamps. So we have to choose appropriate value out of these two. So if VGS must be greater than VGST, if we choose ID, VGS has to satisfy this. VGS is equals to, so ID from this approximation, ID is going to be 0.53 milliamps. So VDS is nothing but 15 minus 0.53 into, that is 7, which is equals to, which we get as from this, V0 is equals to 11.3 volts, that is option A is correct. Comes to the voltage gain calculation in the part B. Voltage gain is nothing but minus GMRD, because in case of an AC case, the CS is going to, RS is going to be bypassed by CS, so RS is not going to be influenced in reducing the gain. So it is minus 2000 into 10 power minus 6, RD is 6 into 10 power 3. So minus 2 into 6, which is equals to minus 12, that is, these are all minus 2's, minus. So there is option A is correct. The initial contents of DE and HL page are given as 5472H and 4528H respectively, and all the flags are set initially. So for the following program, we have to find out the following, we have to answer the following questions. The value of the accumulator after the execution of the program, RET. So we have to find out the accumulator content after the execution of the program. Here in the first case, what we are trying to do is, we are performing EL addition, and then after we performing DH addition. So after complete addition, we are keeping MVI. Before executing a written instruction, we are loading A with 00. So the accumulator must contain the 00 before means after execution of written instruction. So the data is not going to be affected after written instruction. So option A is correct. Comes to the carry flag is set to. See, after the written instruction, the carry flag is depends upon the last arithmetic instruction before execution of RET. The rotate left carry, rotate accumulator left. So it is here, this is the accumulator content. Here 1 to 8, because accumulator is an 8-bit resistor. This is a carry flag. This is D7th bit, D0 bit. RLC instruction keeps the D7 in carry as well as here. So D7 bit, before performing RLC, accumulator contains 00H. So 0 is going to be pushed into the carry before written instruction. So after execution also, carry flags are not going to be affected because of written instruction. So option A is correct.